Okay, there we go. Seem to be live on YouTube. Um, this is just me recording, kind of for historical reasons, um, or for a record, how I using the CSV log controller from Lupis the Canine. It's something I reached out in one of the Discord communities, and Lupus the Canine said they had this controller. I just didn't have time to set it up until now. You can get it on the workshop. Just search for CSV log or Stormlogger. So you need the microcontroller and you need the Git hub code, which looks like this. All I've done is I've extracted this to my desktop in a folder. It can be on your C drive, on your desktop. So that's what you get. You need to make sure you get this one here. I've spelled it wrong on the folder. Oh no, it's right. Which has got the exe in it. The Stormlogger exe is what you really need. And as far as I know, this can just sit on your PC. You run it before you do anything. And I'll show you what happens with this a little bit later. So you can see here I've started to create some data in CSV format. But I'll go into Stormworks to talk about how we set that up. So I'm just going to bring up my so I can see I can see your comments and chats if anybody actually watches this live. Right, so back into Stormworks. I'm just doing a sandbox mode or a creative mode game here. I'm using let me just check the creator of this because I want to give credit as well. So I'll have a look at my favorited items. Using this research ship, which is really nice. It's diesel electric. I'm not too sure. Maybe I haven't favorited it yet. No. So let's go back. I think it's. Sorry about this being a bit clunky. Should be in my top 10. Yeah, this is still showing my favorited items. Why is that? Subscribed items, that's why. Where is it? Where the hell is it? Where the hell is it? As you can see, I subscribe to a lot of engines. That's a project I'll talk about in the near future. So, where's this vessel? I'm just doing this so I can credit the creator of this, because without the creators, this one. So I'm using the Almeria by 454SS workshop. I'm using this just because it's got an electric propulsion and a diesel propulsion. It's got a nice big machinery room. You'll see it in the game right now. So I'm going to go into the workbench and I'll show you how I've set this up. So let's zoom in here, and just going to double check on OSV, still OBS, sorry, to make sure it's getting my sound right. It's all good. So I've not really touched the vessel. It's got a lot of logic in it already. The only thing I've done, and I can clean this up a bit here, is that I've stuck in the chip. So this is the microcontroller, the CSV log. You by default need to power it. So this is just an on-off switch. And I've got a button connected to this other output here, which is reconnect, which is by default off. And the transmit button is by default on. So basically that means that it's working, it's transmitting at all time. I'm going to rebuild this and put it on the bridge. Maybe I'll do it tonight actually. And then I've put the little display in here. So you just hook up the display to the video output. So it's just from that to that. And it's got a little power button that's connected to power. So this is part one. It's pretty straightforward. You basically put that box down and you connect two switches to it, or you can connect what I've realized now are these logic things which are called always on. If I can find it. Always. It's always hard to find these stuff. So let's see, it's in this logic stuff, and it's simply a constant on signal. So basically I can replace what I've done there. I can put this constant on signal. Any way to get something off of your... I want to just have nothing on my mouse. Anyway, so the CSV log, something that turns the transmittant on and something that allows you to reconnect. I've just connected these. I don't think I need them on. And then a display which will tell me the status of it. So that's one thing. I'm going to put it on the bridge. The second thing is, and it wasn't obvious, and it won't be obvious in the description, you need to make a microcontroller that collects the data and turns it into composite. So that's what I've got here, and I'll show you what that looks like. So load, let's do version 2. So it's basically, I knew I needed a composite output because that's what the CSV logger microcontroller reads. And I've just at the moment got 2 number inputs. So basically it's the engine number 1 RPM and the engine number 1 temperature. And then the logic of that, so these are 2 numeric inputs. I'm the king of typos. Temperature. That's a bit better. It doesn't need a full stop. And then again, I looked at Mr. New Jersey's videos. So this basically said, all right, these are the 2 inputs I got, which was a number coming from a machine. It simply goes into what are these things called? No idea. They're called logic gates. So basically, it makes it into a composite signal, and that composite signal goes from this logic gate into what eventually becomes a composite data output. So basically you can take multiple inputs and you can send them over one cable effectively. So I think in real life this would be a sensor on the main engine, and you would have a cable, or maybe IoT kind of Wi-Fi stuff, would send the signal into this you would have your main engine somewhere else. It would be connecting to this input node of this PLC, this product logic control, I think they're called, and other sensors as well. And then this microchip would basically turn that into one composite signal that could go through a single cable to the other chip. So again, so 2 inputs, and I've simply turned that into one composite data output. And that's what this chip is. How do I quit that? So this chip here, if you look at the logic, let's look at the in-out. It's connected to this medium, or is it a large engine here, that large engine temperature and the large engine RPS. And then it's connected with the composite all the way over in the front here to that box. So this box is now getting input. You'll see why. So this is a little bit of a tricky thing. So I'll go back to that thing just to show you. So actually, if I click on this, I've put start channel and count channel 2. So this means that this is channel 2 and this is channel 3. So it's starting at 2. It's not starting at 1. And the reason is that the other box, the CSV log, is the number 1 channel is hard coded. In my case, I've got an older version of it. It's hard coded to time. So I've got channel 2 and channel 3 here, and they're going through that composite thing all the way over there, and that's reading this composite signal in. And then if I click on it, you'll see that we can configure this here. So I didn't touch this data format. This is a thing in the script which is included with this. I'm using a 1 Hertz, which is 1 per second sampling frequency. I want to make it smaller actually. I'm going to try 0.1. Again, I haven't touched this. All I've done here was on this version it's hard coded to record time here. I think in seconds. So if you get the one from the workshop, this might behave a bit different. You won't get time by default. Channel 2 is enabled, and I've just given it the label engine 1 RPM. So this is what appears in your Excel sheet, so your CSV. And channel 3 is enabled, and that's engine 1 temperature. So this is all set up, ready to go now. Hopefully you'll get an idea of how this works in a very basic way. As I said, during this live stream, I'm going to repackage it and see if I can put it up on the bridge a bit more like a real kind of box. So I'm up on the ship, and let's just take her for a wee sail. So as soon as I turn the systems on, it should start logging data because we're basically putting the electrical power on. Let's start the engines. So no warning signs, temperatures creeping up, and RPM will settle more or less. So I'm recording RPM and temperature, remember. On a real ship, you need to let the engine warm up for probably about 30 minutes minimum, depending on the size of the engine, how warm it was before. But basically, there's a lot of kind of metal that you want to heat up until it's at a kind of nice homogeneous temperature, or at least it's not going to warp too badly if you give it full welly. But this is Stormworks, so there's none of that modeled. It's got an automatic clutch system, this vessel. It's very nice. So we can pull away nice and smoothly there. You can see slow RPM on the props. And that's all the gearbox which is determining that. And basically I want to try and do something that's a realistic operational profile to try and get some data which looks realistic in my CSV file. Just in case you're wondering, I want to get the CSV file and ultimately put it into a data historian. I work for a company which has the OSIsoft's Pi software now. It's part of our portfolio, and I want to see what I can do with the visualization engine they've got. But stage one is just to figure out how to collect data. So let's just do a little voyage here. Remember, it's collecting data at a one time per second frequency, as far as I remember. That's what 1 hertz means. We've got a really cool autopilot on this vessel. I'm going to use that, and you just click on your waypoints here. And let's just click on a few waypoints like this. I'll just take her around the island here. This is how you do it in real life, except your chart displays much more high resolution. But this is absolutely amazing considering it's a game. Better than any ship simulator I've ever used. So we want to engage autopilot, and it will start tracing towards these tracks. I'm going to go over, so we've kind of cruised out of our harbour, as you can see there. So the captain doesn't usually sit down when you're kind of coming out. Well, you might do, but I certainly, if I'm on the bridge, I like to have a look around. So we're nice and safe out the harbour. Engine's probably warmed up, or that's sort of things I like to imagine when I'm playing this game. So we'll bring her up. She's got about 6-7 knots. So she's not super fast vessel for Stormworks, but she's realistic, which is one of the reasons I'm using this creation. And one of the other things we've got going on here is we've got actually electrical power. So I'm just going to hit 2, put it up to 25, and you can see there that's giving us a speed boost. And now we're turning. I'm now just going to bring her up to what you call maximum continuous rating, as far as I remember. So she's doing about 16 knots now. One thing I noticed is that when you bring your speed up in Stormworks, the speed pretty much instantly increases. On a big heavy vessel, that's much less of the case in reality. I would be interested if to know, what's the best way to do that. Is it by making the ship heavier? Is it just simply the limits of the physics in the game? This is a fairly big vessel for, the standard build box. I know, of course, that the resistance is not particularly well modeled, so there's not really a detailed resistance, model going on using these physics bodies here. Again, it's an approximation. So, I think we actually have on this spawn, we have the nuclear power station right next to the start island. That's pretty handy. Okay, some birds in the water there. So my long-term plan with this is to hook up wind. So basically I've got weather, maybe wind and precipitation. You actually really need wind. You can work out the waves. Engine 1, 2, 3, 4, just so you can see that all engines are operating the same, and of course, because of the logic in Stormworks, they'll probably be all operating identically, which is not the case in real life, of course. I want to transfer the whole kind of logging system onto some of the older vessels, where I can do some funny simulations like turn off the cooling water valves and see how long it takes for the engine to explode and stop. But on this vessel, it's just my very, very first test bed. So, actually what I'm going to do is slow her down, since we don't really have good... it's not really the ship, it's not set up for me to do a proper test. What I would ultimately do is sail the vessel, bring it into port and do a kind of real simulation of an operational procedure. So maybe by the end of the stream I'll have that running. It's quite late for me here. But let's just slow her down gradually. Let's just bring her to a full stop. In fact, let's do a bit of reverse. Let's see how that shows up on our charts. So we are stopped here. Now, this is why I'm going to move it up on the bridge. So it's down here in the room with all the logic. And yeah, I'm a bit stuck here because it's I'm not in quite the right place. So let me just fly around a bit. All right, so I want to just turn it off, and you just saw there that it actually changes the status there. So this was saying transmitting, which means it's writing to the CSV file, and now it's just saying connected. And the important thing was to show you that this is the exe. So it's basically saying connected. I'm not too sure why it's done it twice, and then it tells you the values that it's writing out. So the exciting part, let's go to my file explorer. Just make sure I'm on top down. 16 megabyte CSV file. There you go. So this is, I'm assuming, I don't know what value this is. It's not seconds. It's not seconds, but as you can see, it goes up. And then here, I've got RPM, which doesn't seem right because the RPM that was displaying was about 300. But I am getting a value, and as you can see here, engine was, that's a bit weird. So why is there RPM when the engine was off? Okay, that is something to figure out. But you can see here, temperature goes up. So it's getting the trend of the data, which is the most important thing. Oh, no, it's not getting the trend. Oh yeah, it's getting the trend. It goes up, and then it goes down, and then it goes off. So the cool thing is, don't make any changes to this, don't save. Let's just open another Alright, this is the generator starting up. So I was trying to open another Chrome. I'll just use a Chrome tab. And I got a link to this thing called CSV plot. So let me just quit Stormworks to get rid of the generator sound. That's that diesel electric ship has got automatic generator script, which is why you can hear all that noise. So where was I? CSV plot, load CSV file, and I get the latest one here. And there you go. I've got my engine RPM over time as far as I can tell. So we can just double check this. It's done it automatically. Time, engine RPM. So we started off slow. I've still got the feeling that that's actually adding up the numbers. It was pretty constant there. Not too sure why it's increased. Maybe it increases because the boat speed increases through the water. Anyway, hit the throttle, so it goes up. Just a line. Actually, it's quite good to see the data points. Starts to flatten out, and then again hit the throttle, and then okay, this is how I know it's not accumulative. So it's flattening out there. I'm not too sure what this bump is. So this could have been the weather that the waves started to kick in. Really not quite too sure why you get this kind of stuff. Should have been flat there. I remember. I hit the electrical power. So this was actually the revs of the main engine dropping off because it didn't need to use so much power. And then I hit the throttle again up to full speed, slowed it down a bit, and then decided to slow it down. I'm not too sure if this is where I did reverse and switched it to reverse. The other thing to do is do temperature. So this is where temperature, it's not very accurate, so it kind of is off, although it should have had an ambient value. Then it goes up and it creeps down. And then of course as I increase the throttle it goes up. And again increase the throttle it goes up. And I should have seen a little drop. Maybe this is where I put the electrical power in here. And then again increase the throttle, decrease the throttle, decrease the throttle. And then yeah, this was reversing. So I was hitting the throttle, it was reversing, and then it slowed down. So that actually does kind of reflect what I'd expect to see from the data. Let's go back in and fix this up a bit better. So I think I'm going to sacrifice. I'm thinking about this. So I'm just going to rebuild this all up in the bridge. So I wish there was a slightly faster fly mode. Okay. So let's just blow all this away. And build it up on the bridge. So there's plenty of room on the bridge. Now, let's just make this a sort of, need a kind of wall to put this on. Let's build a wall for it. Haven't built for a while in here. No. Excuse my horrible building skills. Right. And then we're going to have buttons. A couple of toggle buttons. Let's have the display at the top. What's that display? 1 by 2, 1 by 3, 2 by 3. It's a bit big. And then it was microcontrollers. So I might have two now, quite interested to see. Workshop microcontrollers. Let's put the workshop one in. Means I won't get time. Or maybe I will. If anybody knows how to move something that's already in place, please let me know. Because I would really like to do that. So what did I have to do? And I want an always on for the display, don't I? Constant on signal. Right, I think that's it. So, again, anybody know how to how do you manage that? These people who build this stuff, electrical. So, what needs electricity here? Everything. Can I just connect this to anything else that's got electricity? Will that work? Let's try that. Data. Transmit. My God, can't see. Sorry. So, transmit on off. The bottom one. Reconnect. Top one. Constant on. Where does this go? Monitor. Oh, it's on. Oh, is that it? Composite. Video, right? And then just had a good idea. Have I finished here? Electric. And then let me just connect it to that old one, CSV data logger. And then, all right, so it's only putting into channels 2 and 3. So sampling frequency. Let's keep this the same. Is it RPS, RPM? I don't know. Maybe it's RPM that comes out. That would be ironic. Channel name. Temperature. Engine temp. Let's keep it short. Disabled. Enabled, enabled. And time. Let's just have nothing going in there. So this should work now. This is on. So there's 1, 2, 3. Ooh. Does that mean it's been? It might mean it's been running. Even here, let's save it. She's spawning in. And then there we go, connected. Transmitting. So it does do it even when the engine's not on. I just realized I can put the clock in. Well, let's just get some data. Right, went to full speed. Then I'm adding full electrical. So the RPM's going up because the ship's going faster. What happens with the temperature? 45, 46, going up. Still going up as I decrease the electricity. And then we stop. Get off the seat. Finishing transmission. And then, oh, this is what I forgot last time. Oh, electrical power's off. So then we go to this F5 it, 2 kilobyte file. Test value 0, engine RPM, engine temperature. Looks good. So it's working. Now let's do time. Take it back to the workbench. It's got to be a clock, hasn't there? Clock. Right, I'm going to put clock down here. Oh, and it's not up. Get rid of that one. Now, what do I need to connect into clock? Oh shit. Clock has a time as an output and a backlight. Time as an output as a factor of a day. Alright, that'll give me something. So does the clock need electrical power? Yes, and then I find out you can daisy chain like that. Then I need to go back to this. Open V2. Add. It's a numeric value. Then we're going to put that there. Time is the third one. Logic is there. Time is the third one. 3. Save. Now what I didn't see is, does this automatically get a third? No, it doesn't. So we're going to go and delete that. Put it back in again, which is the PLC version 2. That one. Sorry that I'm talking through. Well, I'm talking through book for the video, right? Of course. Connect it up again. Time. Engine 1, RPM. Temperatures at the top. Click. RPS. Seems to be changing the. Ah, yeah. 12 RPS times by 60. Okay, that's fine. RPS. We've got everything. Clock is connected. Blah 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 blah. And then composite again up to the bridge. So we'll filter on composite. Draw this all the way up here. That's quite nice. Easy to see. And then I do need to go on L. change channel 4, 2, 3, 4 to this one, which is time. Save the whole thing. Launch it. And again, ready to go. So connect it. Turn the engines on. Oh, let's do that before the engines are on. So transmitting. I just trust it. It's transmitting. Engines on. And I can go to the DOS thing. There we go. So it's done it twice. Created, connected. I guess that's when it's when I'm in the build mode. The default wasn't on. All right. I don't mind having 2 Excel files. So let's have a dynamic weather. And off she goes. So I assume that I need a bit of time to pass before this works. This ship sounds good as well. Yeah, so RPM must be just what's it, getting about 12 or so on times by 60. So somebody's just done that script. And assuming that I could do that in a Lua script, get an RPM. Okay, that's all fine, all doable. So the next thing I want to add to it is to get a fuel consumption. So I'm not too sure. Let's just go and have a look at the engine here and see what's happening. So in the engine room, let me get back in here. So in the engine room, what data do we get here? Temperature. Okay, temperature was alright. Fuel. Oh, that's off. Let's have a look at an engine which is running. So it's this engine here. It's the only one that's hooked up. So I'm getting fuel liters per second divided by 4L. Not too sure what that is. I can get liters per second. I can get air. Don't care about that. Exhaust might be interesting because I can measure pollution. And I'm not too sure what the in-co and out-co are. Okay, I need to see how this works on a modular engine as well, like where the sensors are. Is that per cylinder? Could be. Which is more like a real vessel. You'd actually measure per cylinder temperature and maybe fuel injection, how much is going through the fuel injectors, not too sure. Yeah, so the next thing is to at least do is my data collector. Got a clock. So I'm only going to have minutes on this by the looks of it. So I'm going to let a couple of minutes pass. Large engine. Yeah, so let's just get back up the bridge. We'll just run it for at least a minute. I'm going to bring her up to cruising speed. So what I expect to see is some fluctuations in the I'd like to see engine speed versus propeller speed. I mean, it should be mechanically coupled, so it should be related. But what I'm expecting is we'll get slight fluctuations in RPS, revolutions, or engine speed, basically as we go through waves. Because there'll be a little bit of resistance, and it might speed up or slow down over the water over the propeller, so we'll see variations in that. I'll bring her up to a little bit more. There must be a clock in here somewhere. No clock. Have a look over here. Depth sounder. Anchor. Let's get those bridge lights on. Transmitting. I need to put something in here which is basically showing how many megabits per second. Cool stuff, huh? Haha. Right. It's been running for about a minute, I reckon. Let's just stop transmitting. So I'll keep her running. It's ended. Straight into the CSV file. So, time. Not changing. Do we see anybody changes there? Alright, time is going to be difficult. I will figure out how to do that one. In the meantime, we go back to the workbench for another iteration. So main change this time is going to swap out the workshop version of the CSV logger because I like the one that's got the hard-coded time on it. And that was to delete that one and get microcontrollers, which are saved by me. CSV log, that's it. And then if I can remember how to get up again, so let's just do this most important one. So it's now getting data. Here we go. Let's just view like that. I'll make it easier. And then we wanted to get transmit on and off, which was the lower button. No. I'm sorry. That one goes to that one. That one goes to that one. And that was it. Time should still be included. I have to go and configure that. So time. And this was engine 1 RPS. Eng 1 temp. Right, so back to where I was. I've got time, engine, temperature. So let's go back. I'm stupid because I'm going to have to do this again. Fuel. Right, where did I get that from? Ah yeah, so the engine did have a fuel. Now I need to kind of isolate this graphically. so I can figure out where to get these data points from. Feel. So we did see this as something that pops up over it, but we're not seeing that anywhere here. So where was that fuel coming from? Where was the fuel coming from? Fuel. Radiator. Odd. Little pump at the back here. The camera. Okay, down the bottom. Alright, I'm not going to figure out how to do fuel consumption. Let's take this and do... I wanted to not have this view. How do I do that? It's that one. Design. Let's just change this to engine 2. Okay. Did fix that previously. Engine 2 RPS. I want engine 2 RPS, and we add another. Yep. Keep things short if you can. Ooh, what the hell is that? I've just pasted there. Pretty sure I changed that. Eng to temp. And not too sure if these descriptions are used anywhere, but that's nice. So at the top I want RPS 1, RPS 2, temperature, temperature. Do the logic. 2, 3, 4, 5. 2, 3, 4, 5. We're good. Now, get rid of the old one. Don't need the clock. Put the new one in. Connect it to some more things. So the top two are temperature, bottom two are RPS. Temperature, right hand side. Right, got all our inputs. We need to connect the composite. To the bridge again. Quite flashy. We need to connect the video to make that work. Alright, I think we're done. So now I should have two engines. And I'm going to go for a bit of a sail this time, I think. I'm going to save it. And override weather off, right? So we've got weather. Connected, transmitting, thank you very much. Everything on. Right, I'm going to let the temperature settle. Just something that I've forgotten, which was the value of, what was it, the frequency sampling, you see, there you go. So I want to do it at 0.2 of a second, 0.2. Save. So saving the whole lot. The other thing I'm going to do, now that I've done that, is go here. Whoa. Yep. Any way to get that to be where I am? So this is just a way of saving this out to the workshop. Here we go. It's pretty good, this stuff. I want the screen as well. So this captures the components you've got here and all the logic, which is not much in this case. So there's my little box. What do I do now? Copy. Save it. I'll just put like that in case I upload it. So there we go. I don't need that anymore. I've changed the frequency. So let's go back. Chip spawns in. Connected is good. Transmitting is better. The weather's picking up. So it should only be doing it every, is that 5 seconds now? That's what I changed on the frequency. So we're getting some beeps. Let's just let the engine temperature settle like a real vessel. Okay, let's get out of here. I think getting collision warnings just because we're moving around so much in the wind here. Normally have some people watching out for you here. We're going pretty straight. Transmitting. We're clear. Okay, give it a bit more juice. So I should be recording two engines now. The RPS of the engines and what else was it? Temperature. So I just want to do a little test. I'll go full speed, 15, 16 knots, 17 knots, 17 knots. I'm into the wind as far as I can tell. I'm going to come around the corner here to see what happens to our speed. So we're in a turn, so we're 17 knots into the waves. RPM 834, okay. I just want to see if it increases as we go with the waves. The ship's got a stabilization system, let's put that on. It's little motors, as far as I could tell, on the bottom that are just thrusting up against the... That works quite well actually. So we're actually not getting any more speed. Got 4 RPM more. Now it's settling down a bit. So it's not going to go up to that 17 knot speed that we had against the waves, which is weird. Unless it's magically measuring speed through water, which it could be, which is interesting. So speed over ground, probably more. Speed through the water, less, assuming that the waves are moving here. Pretty cool for the Stormworks developers if that's the case. You can see here I'm surfing a wave. Yeah, makes sense. Speed over ground high, speed through water lower. Probably. Let's just do that again. We'll see what 840, 35 as we do turns. I'm not too sure. Struggling against the extra resistance of the turn, perhaps. Yeah, I did see 17 there for a second. Let's see. Waves are getting bigger though. (16, 17, 18), yeah, so speed through the water is higher. So I need to get a GPS speed. That's the next thing. To get a bunch of data from a GPS chip. Right, so let's slow her down. Let's stop the data transmitting. Check our DOS file, and we go back. Check our latest one, I'll do F5. Not much data, okay. So yeah, time is going up, no idea what that time value is. Engine looks good, temperature looks good. So then I'm going to pump it into our CSV logger. So you get to see all my history there. CSV plot is called. Remember. Ooh. Okay, so now we need to do... Ooh, this looks funny. This looks wrong. Oh. Okay, so it's measured at a lower frequency. That's good. It's not recorded second set of data because I haven't changed it. So temperature, up, down, up, down, up, down. So this is interesting that I've done a lower frequency, so I'm getting a kind of more realistic thing. So there was our temperature. Let's see engine RPS again when I was doing those turns. Very slight downwards and back up again. So less data points, very interesting. Alright, I'm going to do a longer sail, but I've obviously forgotten to add my other things in here. I'm going to leave this stream for now. So this has been me just figuring out how to do data logging in Stormworks. I hope it's interesting reference to you. So the link to the script which I'm using is it's in the workshop, and I've put the link in the description hopefully. If not, you need to look for Lupis the Canine or CSV Logger. And that's all for now. Cheers, and I'll end the stream.